Hi, I thought I'd do a quick update on the Z80 project. After a lot of troubleshooting, I never did figure out the noise issue on the board, so I've actually recreated the whole circuit, a bit more of a compact design on a bit of a higher quality bit of board, which I'll show you in a minute. I've only just a second made some modifications to it. I'm actually now using a 74 LS14 hex Schmidt trigger, or hex inverting Schmidt trigger for that now. I was previously using a 744 to invert the reset signal to go to the 8255, but what I did is I just swapped the chips over because they're pin-for-pin compatible, and instead of the reset coming directly to the bottom now, it goes through a second inverter after the first inversion to make sure that the signal is the Schmidt trigger to clean it up. And I've also done that with the NMI. But anyway, yeah, those chips arrived this morning. I was actually going to video today showing you the board in its current state, and because I've actually got a bit of success with it, although I do have some more problems, but you know, one step at a time. So anyway, straight to the bench. Okay, so here's the board as it is now. It's working. Sorry about the mess and the poor lighting. I just really haven't had any time to do anything. Lots of tests at the college. But yeah, these boards are a bit better than the other ones. I'm trying to get an example. Okay, so this was the other type of board I'm using. This is the board I'm using now, and as you can see, it's actually designed for logic, pretty much. And that's what I've done. It's a bit of a mess, so I'll leave it. It's actually running right now. So there's the 8255. I put the bloody ZIF socket in the wrong way around again. Yeah, seems to be a new tradition for me. So there we go. There's pin 1 there. It's the exact same circuit as before, except actually I've added a button. And this is port A coming out, and I believe the button is port C7, but I haven't done any tests with reading yet. Oh yeah, so the difference between these two boards. This one is just point-to-point holes, and this one is that. Yeah, anyway. So yeah, this is now running. I don't know if you can tell by the video or not. This is actually flashing really fast. So if I come here, if I get some focus on that, 339.6 Hertz, which is good. Now this button's the NMI. That's reset. So basically, I told it NMI takes it into a subroutine where it sets the port off and then loops endlessly. So there we go. And so reset will basically bring it. Right, you can see it brightens up when I hold the reset button down. That's because by default it is on with the 8255, and if I let go, it dims a bit because it's like it's actually a PWM type action is why it's dimmed. But it is working, so that I'm happy about. But yeah, my biggest problem with this board right now is if I do any like delay loops and stuff, it doesn't seem to work properly. I did all the usual RAM read-write tests and stuff, and they seem to be fine. Now, the program I got in here is it actually increments each time in a loop and sends that to port B. So this is actually counting up in binary really fast right now. So actually, if let's put that on, what is it? This is 0 here, I think. Nope. It's hard to do this on camera. There we go. See, 43.47 kilohertz, and the next pin should be slower in capture. Yeah, so it should be half each time practically as we go along. So I am writing to the 8255 and I'm seeing that, so that is good. I'm happy. This is progress. But I do have to double check with the code that I'm getting out that it is compiling correctly, because that may be a problem. So anyway, so we'll go to the computer and I'll step you through the code. Okay, on the way back to the computer, I've actually thought I'd quickly add a power switch and I hot glue the power connector in. Thought I'd give you a quick look at the back as well while I'm here. Yeah, a little bit on the messy side. It's all the pull-up and yeah, all the pull-up resistors are all on the underside as well. As well as decoupling caps. If you can see a couple of them. Yeah. So that's the board with the 4 MHz crystal again, and yeah, A7 and C7 for the button and the light there. So yeah. Okay, so I'll continue on to table. Oop. Okay, so what we have here is the schematic diagram. Now it's pretty much the same as before. Actually, I'm not showing all the resistors here. What I did this time, let's see, last time I only did the inputs, but this time I actually did all the outputs. Any active low pin here, I just put a resistor on and pulled it high. I kept the same expansion bus because the my logic analyzer uses it, so I've already got a cable for it. So we've got the same ROM, the same RAM, same clock, an 8255. So now what I did differently is, instead of the reset going directly to the Z80's reset, it comes in here, gets inverted, so the 8255, because that needs a positive pulse for the reset, which is quite annoying, and then it gets inverted again and goes to the Z80. But these are Schmidt triggers, so the signal's much cleaner. You know, less bouncing on the thing. So that actually connects to here. Now I did find I had to actually pull up the button itself, because it was on the other side of the inverter, and same with the NMI button. That keeps it clean as well. Now with the 8255 expansion, this is the same. You'll notice I removed the IO expansion bus. I got space on the board to add something else like that afterwards if I need to, so I'm not worried about it right now. So I just have a switch coming in to C7. I haven't done anything with that yet, so that's for later on. And then the same configuration with the output. So yeah, so that's that. Although I did actually have a diode reverse polarity protection here, as well as a switch, which I haven't shown. Okay, so that's the schematic. Okay, so here's the software that I actually have in the chip right now. Basically, upon reset, we basically set all the ports as output, and then we send that to register 3, which is the config register. Basically this is bit 16, no, bit 16, that's a bloody byte, okay, sorry, bit 7 is set high, all the rest are low, which basically is enable the 8255, everything as outputs, and mode 0. And then it jumps to the start, which is here. Then basically it initializes the A register, the accumulator, to 0, and then increments it, and then sends that to the output port. Sorry, actually it sends it to the memory address 4000, which is what I used to have a look to make sure it's working, and then it sends it to the sorry, and then it sends it to the 8255 and register 00, which is the A port. Now, when I had this working yesterday, I think it was yesterday morning, I was working on this, and I was sending it to the C port, and I was scratching my head and wondering why nothing was coming out, so yeah, I figured that out anyway. So it does that, and then it loops around increments, and obviously when it gets past FF it goes back to 00. And since the LED is on bit 7, only when it reaches past Z80 and hex will it light up, and then when it reaches 0 it goes back down again. So that's what gives the pulsing. Now if I hit the NMI button at any point, it immediately jumps here, sets the accumulator 0, and then basically outputs 00 to the A port, which basically means turn the A port off, and then it infinitely loops. So that's what we have going. Okay, so I'm going to have a look now on the logic sniffer. I should have done this before doing. Okay, let's make sure we're on. And capture, right. Right. I was going to say, why is the NMI low, but we're doing hourly encoding, which the last bit is always low, according to this, which is the NMI. I should have interchanged it with a refresh. Ah well. But anyway, yeah, so now if we coincide, in fact what I'll do is I will compress it a little bit down. There we go. We don't need to see the waveforms for the data and the addresses. But what I'll do, right. Now we'll see there's the right signals. So I'll just highlight I'll highlight about 6 of them. Right. Now, as we can see here, on this right signal, we're writing to address 4000 with the byte of 1. So that is where it's going into the memory. And then you'll notice over here, let's look, the I/O is high, so it's disabled. What is that there? And the memory request is low, so that's a memory write. And over here, the I/O is low and the memory request is high, so that's a memory request. So basically, memory address 0000. Well, at the moment we're ignoring this high address byte here. We're only reading the bottom one. So 00, that is the port A. So it writes 01. No, it didn't capture the setup byte for some reason. Or did it? Yeah, it did. Sorry, it's right here. The setup byte 0003, which is the command register for the 8255 and 80, just as we shown here. Okay. So we have, there's writing 01 to the memory, then the I/O, then 02 to the memory address 4000, and I/O 00 goes to 2 again. And same with this. So that shows you it is actually working. Now if I skip along a little bit, and we'll have a look. So this is right, without the whistle, right, memory request, well that's 1B, so the next I/O, so that is low I/O, the memory is high, 1B. So yeah, so you can see how far did we capture? 1D, that's how far we captured. Now, let's see. Okay. Now, I'm going to put this into NMI mode. The light has gone off, and capture. Oh. All cursors. And then basically now all you'll see is there's no writes, only reads, because basically the is that correct? Oh yeah, that's right. It's basically reading from sorry, I'm tired today. Okay, so it's reading from the address here. Basically it's telling it to jump back around into the loop, so that's what it's doing. And oh yeah, I was wondering why I was seeing 34 here. And then it's 35, but you gotta look, that's where the refresh is. I just wish there was a way to filter out anything with the refresh, because that's the only annoying thing about debugging the Z80 for me. Okay, so basically this says here, this is jump conditionally to address 006C, and that's what it does, 006C, and then says it again and again and again, because it's that's this line here. So yeah, so we have the memory read and write working, and at long last we have some output going on. But the next thing I need to do is to work on delays so I can slow it down, and then some input. That would be good. Yeah, so hopefully the next episode we'll be looking at input and output, and see what we can do from there. Well, thankfully we made some improvements of the board. Sorry it took so long to do it, but been doing a few tests at the college, unfortunately. Chemistry and biology, not the easiest subjects, but they're fun, and I need it all to get to university. But yeah. So I got this week and next week, and then I have a week off. So I will be doing a lot more work on the Z80 next week, or in that week. I'll be definitely aiming to get some done this weekend, and yeah. So like I said in the previous segment, I will be working on input next time, get that working, and then we can see what we can do. Probably after we get the input working, or maybe alongside it, I might try and get the LCD screen working. That would be nice to actually have some proper output on the screen and see what's going on. Yeah, so until then, thanks for watching, and I'll catch you next time. Goodbye.